Based on the question, there were no ratios provided. Can I have your attention? But we were told that S is a midpoint. If S is a midpoint, it means RQ is bisected. Okay? It means RQ is bisected. Also, T is a midpoint of PS. So T is a midpoint of PS. So PT and TS will be equal. Okay? Then MTW is parallel to PQ. Right? Now, for this question, because it's talking about the midpoint here and the midpoint there, it means you might need to use the midpoint theorem or the converse of the midpoint theorem to do the question. Right? So the first question says, calculate the numerical value of the following Rm over Rp. So you want to calculate the numerical value of Rm over Rp.
Can we have the hockey boys, please, that are going to Redham, to come down to the buses now? The hockey boys going to Redham, please can you come down to the buses now? Thank
you. Okay, I need to carry on. So we've got Rm over Rp. Right, so this will be Rm and then Rp, that will be the bigger one there. Now there are two possibilities there. Okay, the question it has got 6 marks, right? Which means there is maybe a bit of some working out that has to happen. Okay, so what I'm going to do first is I'm going to use the midpoint. Okay, I'll use the midpoint of PS, this T here. If that's the midpoint and MT is parallel, in this case it's going to be parallel to PQ. Okay, which means there is no direct relationship between triangle PSQ and triangle PRQ. There's no direct relationship. So I can only apply the proportion theorem in triangle PSQ, or I can apply it, I think that's the only triangle. Okay? There's no other triangle. Okay? But it's also important for you to be aware that in triangle PSR, I can apply the midpoint theorem or the converse. Because if this line here is parallel, but in this case we are not told that it's parallel to what? To RS. Therefore, we cannot also apply the midpoint theorem or the converse. Right? Which means you might have to look at areas, if possible, for you to be able to get that ratio there. There is no numerical information. Right, so the way that I'm going to do the question is I'm going to determine first the ratios. Okay, I'm going to find the ratios of PM and PR using the information that's given. So first thing, if I call in triangle P, I'll use triangle PSQ. In triangle PSQ. Okay, in that triangle, I can use the converse of the midpoint theorem, which means if I have this as x, that will be x. Okay, obviously this point here I need to prove that it's also a what? A midpoint. So in that triangle, I can say SW is going to be equal to WQ. Okay, my reason here, I'm going to give my reason as the converse of the midpoint theorem. Okay, so this will be line through midpoint parallel to second side. Okay, so SW is going to be equal to WQ. So what I can do here is I can make this Y Okay, do you understand why I'm using the convex for this statement?
Yes, but I have a question. So what I did was I said ST is equal to TP, so the ratio between them is 1 over 1, so it's just 1, and that ratio is equal to SW over WQ, so then they have to be equal.
Okay, it's fine. If you use that is fine as well. So you could go via that way, use ratios to prove that these two are equal. Okay, so if this is x, that's x, so I can call that one y, and then that one is gonna be y. Now, since we are told that, and then I'll say PS is equal to SQ. Now, these two are equal because point S is a midpoint of SQ. Okay, which means I can call this one what? 2y. Okay? Are you following there? Huh? I can call it what? 2y. Then remember the objective is to find the ratio of Rm. This is Rm and Rm over Rp. So those two. Okay. So I've got that. Then the next thing I might, okay, the question, okay, you can find that we haven't done similar triangles. Okay? Because the question might also require application of similar triangles. But we haven't done similar triangles, so we have to do it based on the information we have. Right, now I'm sure you can agree with me that in triangle RPQ, I can apply the proportion theorem. Do you see that? Yes?
How is PS equal to SQ?
Because we are told that S is a midpoint of SQ.
R.
Oh, okay, sorry, I made a mistake. I put P instead of R here. Sorry, this is R. Sorry, this is RS. Sorry, this is RS, please. RS is equal to SQ. Okay? Alright. So from here, okay, we can apply the proportion theorem in triangle PQR. Do you all see that?
Yes.
Huh? Now the question becomes easy. Now I can carry on. Okay, I won't need to use similar triangles, but some questions may require application of similar triangles, but we haven't done similar triangles as yet. So the best route here is to use what? The proportion theorem. Now, before I carry on, I'm sure you, by now you should probably have understood that using the constant makes things what? A little bit easy. It makes all the questions on your grade 12 proportion theorem very, very easy. If you understand that, you won't have any major problems. Okay, so to get this ratio, it's going to be Rm is going to be equivalent to Rw, okay, and P and Rp, okay, Rp is going to be corresponding to Rq. So I'm almost done. Okay, I'm almost done. I'm smiling already. So here I'll just write it in triangle RPQ. In triangle RPQ, I can write my ratio is Rm over Rp is equal to Rw divided by Wq. Sorry, not Wq. It's gonna be, okay, there's Rp, so that would be Rq. Then give your reason here, line parallel to one side of triangle. Okay. Then allow me to use a different color just to distinguish what I've written already. So from here, Rm is going to be equal to Rp. Right? What is Rw? It's going to be 3y. So this will be 3y divided by Rq, which is going to be 4y. So the final answer will be 3 over 4. And then you are done. Okay.
It's the same thing.
Okay. Right, any question? Stan, but who has got a question? Okay, if you don't have a question, then let's move on to the area one. Okay, so we are going to use the information we have. Okay, we are going to use the information we had in the previous on the previous diagram. It's the same diagram, just that I kind of so that's bisected. Okay, that's bisected. And this one is bisected as well. So we said this is y, that's y, and I call this one x, and that one x. So we now want to determine the ratio of the area of triangle RPS. So let me just highlight it. So we have got RPS. So that's RPS. Okay, so that's the triangle there. Then we also have RMW. Okay, let me use a different color just to distinguish them. So that's RMW. So these are the two triangles. Okay? Now, those two triangles, I'm sure you can see that they share a common what? They share a common vertex and a common angle. Okay? Because of that, the question becomes a piece of cake now. Right? Yes, it becomes a piece of cake. Because they share this angle here. So we can use the what? The area rule. Okay? But before we start applying the area rule there, I need to write the length of PM and RM using a constant. Okay? So allow me to use K. So based on this ratio here, RM, okay, RM is, okay, I can call it 3K. Can you have one lesson? Can you have one lesson? So RM, I'm going to call it 3K, right? My PR is going to be 4K based on that. Okay? My PR is going to be what? 4K. Okay, you might have used different constants, it's fine. There's no problem there. So Rn, I'm going to call it 4K, and then PM is going to be K. Okay, this is from common sense actually. Okay, then the question becomes very easy. So this will be equal to half. If I start with RPS, so that will be PS times RS times sine R. This is all over. That's all over the area of RMW. So that will be half times RM times RW times sine R. Okay, question becomes very easy. No increase of your heartbeat because you'll be knowing what to do. So these two cancel out. These two cancel out. So that will be equal to, now PS is going to be 4K. Sorry, PS. Okay, so I wrote this PS there, I made a mistake. It's supposed to be PR. Okay, please, this is supposed to be PR. Okay, please, this is supposed to be PR. So that's PR. That will be 4K times RS, which is 2Y, all over the denominator. We have got RM So Rm is going to be 3K, and then the other one, which is Rw, that's going to be 3Y. Okay, fortunately, the constant will cancel out, and that when that happens, the answer that you get has to be 8 over 9. Okay, and then you are done. Okay, now this is very important. A question like this, you have to get a separate diagram sheet. That's why when you write your maths paper 2, you have got a diagram on the question paper. Then there is also a separate diagram sheet, because the way people answer the question is very different. So however you decide to answer the question, you have to show it on your diagram in terms of whatever you are doing there. You have to show it. So that the person who mark your work, they'll be able to see what you were doing. Because your solution will be a unique solution. It belongs to you. You might have other people who might think exactly the same as you, but the probability has to be less than 100%. Okay, your solution has to be unique. Right? Any question? Any question? Okay, so before I carry on, so far we have done 3 cases of ratios of areas, right? The most straightforward is when 2 triangles share a common vertex and a common height, the ratio of their areas will equal the ratio of their bases. That's the first case. The second case, we have got a case like this one where 2 triangles share a common angle. If you know their dimensions in terms of the constant, you can easily find the ratio of their areas. That's number 2. The third one is the one that I did yesterday, where the 2 triangles that are given don't share a common vertex, they don't share a common height, which means you have to figure out a third triangle which is related to both in terms of the ratio of their areas. Right? There is a fourth case, which I will talk about later, but I have to introduce similar triangles first. Okay, so I'll talk about it later when I introduce similar triangles. Okay, any question? Yes. Yeah, here, this one here, there's a common vertex, yes, but there's also a common angle. You see that they share a common angle here.
So the reason is common vertex.
For this type of equation with the area here, you don't need to give any specific reason. When you write the formula of the areas there, you indicate information on the diagram to be part of your solution. Okay? All right, let's get on. Right, then this one now. Right, with regard to this one, the moment you see your ratios, straight away add that information on the diagram. So we have BD equal to 6 centimeters and CD is 9 centimeters. So this is 6 centimeters and that's 9 centimeters. Then the ratio of AT to TC is 2:1. So I can call this one 2x, and that one I can call it what? X. Okay? Then we need to determine the numerical value of CE over ED. So we have CE over what? ED. Now it's 1 mark. Okay? Which means you can just write the what? The answers. So CE over ED, if we use the proportion theorem in triangle ACD, right? The ratio of XT2 to TA will be equivalent to CE over ED. So your answer here is going to be a half. Okay? You don't have to waste time trying to do unnecessary things because it's 1 mark. Then 1.2 says show that D is the midpoint of BE. So we need to show that this point here, it is a midpoint of BE. Okay? Now, for this question, it's very simple. We just have to determine the length of DE. If DE is equal to 6, then you say, since DE is equal to 6, BD is 6. Therefore, Those two are equal, hence D is a what? A midpoint. So 1.2 is not a very challenging question to do. Okay? So what I would suggest, okay, I might take a long route though, because I'm a teacher, so I need to take a long route there. So I'm going to use the proportion theorem to determine the length of DE. Okay? I'm going to use the proportion theorem because I know that CD is 9. Okay? So I'm going to use one of the corollaries actually. So I'm going to say in triangle is 2 marks. I could try to use a shortcut, but if you want to get full marks to go on the safe side, sometimes it's better to provide more information than what? Less information when it comes to geometry. So in triangle ACD, if I apply the proportion theorem using any one of the 4 corollaries, I can write okay, I'm going to say CD over DE. Okay, CD over DE is going to be equal to AC over, okay, if I say CD is going to correspond to AC and DE is going to correspond to AT. Right? Then you give your reason here, line parallel to one side of triangle. Right? Then from there I'll substitute. Okay, my CD is 9 and DE is the one that I want to calculate. Okay? Then AC is going to be equal to 3x and AT is going to be equal to 2x. Right? So if I do the math here, my DE is going to be equal to 9 times 2 over 3 because these two cancel out. So you end up getting 6. So that's 6 centimeters. Okay? Then here I'll say, therefore, DE is equal to BD. Yeah. Therefore, DE is equal to BD, hence D is a midpoint. D is a midpoint of what? DE. And I'm done. Okay. By doing this, you'll be assured of your 2 full marks. Yes?
So I did a little way with the same concept. So you know in the first question how we worked out CE over DE.
Yes.
So I gave DE and EC a constant. So my constant was 5. So I had 2x and x. So I said 2x plus x is equal to 9, and I solved for x, and then I worked out the DE and x.
Okay, it's fine. Okay, it's fine. No, that's fine. Mathematically, it's 100% correct, so that's also fine. You see, with these geometry questions, we might see the diagram and figure out a way of solving the problem differently. That's quite common, as long as you use the correct math concepts. Okay? As long as you use the correct geometry concepts, then it's fine. Right, then 1.3 says if FD is 2 centimeters, calculate the length of TE. Right, so FD, this length here is 2 centimeters. So that's 2 centimeters. So we need to calculate the length of TE. So TE is from here to there. Okay? Alright. Can I have your attention? Okay, so I'm going to use the midpoint theorem, right? Or rather the converse of it actually. Because we are told here that AD is parallel to what? To TE. Okay? Based on the converse of the midpoint theorem, I can say FD is half of what? TE. So I'm going to use the converse of the midpoint theorem here. Right? Okay. Let me squeeze it somewhere here at the top. Can you pay attention? Pay attention. So from here, I'm going to say in triangle BET, okay? In triangle BET, TE is going to be equal to 2 times FD. And my reason here is the converse of the midpoint theorem. Okay. Why do you think I'm saying the converse? Why? Because if you give your reason as the midpoint theorem, it will be incorrect. Yes. Yeah, we are not told that BF and FT are bisected by FG. So you can't give your reason as the midpoint theorem there. Okay? It has to be the converse. Line through midpoint of parallel to second side of the triangle. So line through midpoint parallel to second side. Okay? Right? Line through midpoint parallel to second side. So that will be your reason. Right? So TE is going to be equal to 2 times 2. And you get what? 4 centimeters. Okay. All right. Let's move on to the areas. So the areas now, we need all the information we got so far. So this is 6 centimeters. That's 6 centimeters. Obviously, this will be 3 centimeters. And this one I called it X, and that one I called it what? 2X. Okay? Now, triangle ADC. Okay, let me quickly get this page. I wonder why. Yeah? Yeah, you might just write the right answer. So triangle ADC, this is ADC, right? Then triangle ABD, okay, so ABD, this is ABD. That's an easy question. Yeah, it's very easy. So how would you get the ratio of the areas of these two? Please, can you pay attention? Don't put your head down. Pay attention and look at it. The ratio of their areas will be equal to the ratio of what? Of their bases. They share a common vertex here, and their bases are going to be along what? BC. The base of ADC is going to be of ADC, so that's ADC is going to be DC, which is what? 9 divided by the base of ABD is going to be what? 6. So the answer here is going to be 3 over what? 2. Are you following, Spoon? Huh? Are you following? I hope you are following. Huh?
Yes, sir.
Okay. Then 1.4.2. You see, these questions, can I have your attention? If you follow what I'm doing, you can answer any question. And you will be smiling. Okay? So, the next one now, so let me do it on the next page. I can do it, I think I've got enough space. So, 1.4.2, the area of triangle TEC. So I need to identify where is my TEC. So TEC is this small triangle here. That's TEC. Then ABC is the bigger one. Then this is very easy. Okay? That will be very, very easy. So I'm sure you can see that they share a common what? Vertex and a common what? Angle. They share a common vertex and a common angle. Because they share a common angle, you can just use the area rule. Okay? No stress, no pressure. Okay? So, in triangle, okay, no need to write in triangle, just write straight away the area. So, area of triangle TEC over the area of triangle ABC, this will be equal to, now, I've got all my dimensions, so it's very simple to do. Okay, so this is going to be a half times TC times CE times TC times CE. Okay, times sine what? Sine C. Over for ABC is going to be a half times AC times BC sine C. Okay? Now, this is easy. So half and half cancel, sine C and sine C cancel. Right? Now, when it comes to TC now, TC I called it X. Right? CE is 3 centimeters. And AC is going to be 15. Okay, sorry, not 15, it's going to be, okay, AC is going to be equal to 3x. Okay, and then BC is going to be equal to 15. So the x and x cancel. So, please, can you do me a favor and pay attention? So these two cancel. So my answer is going to be 1 over. Okay.
Wait, sir, I made it complicated. Sorry, I'll pick it up now. I did the triangle thing. I got the right answer.
Yeah, it's too correct.
But it was a waste of my time.
It's fine.